Hello everyone, welcome to our next lesson. This begins on page 30 in your notes, and this is all about symmetry. Okay, so you're going to see that there are three types of symmetry with regards to a graph, or at least three types that we're going to be looking at. And these would be symmetry in the x-axis. Let me get my marker. Symmetry in the x-axis. You can also have symmetry in the y-axis, and it's also possible to have symmetry in the origin. Okay? Now, unlike the last section, you're not going to be creating new functions that have symmetry or that are reflected, in the x-axis, y-axis, or origin. What you're doing in this section is you're going to be testing a single function, a function that you're given, and the question is this function symmetric with respect to the x-axis, like in this case right here? Or is it symmetric with respect to the y-axis, like this case right here? You can clearly see in the first example, the x-axis is like your mirror, yes? And that's why it's called symmetric with respect to the x-axis. In the second case, it's symmetric with respect to the y-axis because the y-axis acts like a mirror. And in the third case, right here, this shows a graph that's symmetric with respect to the origin. And like I was saying in the previous section, you can think of a symmetry with the origin as a 180-degree rotation about the origin. And that's what they mean by symmetry. You don't really have a line of symmetry there. Instead, there's a point of symmetry. So you're just going to be testing a given function to see if it exhibits any of these three types of symmetry. So what is the test? How do we actually do that? Well, I want you to notice, here's a little clue right here. Look at case number 1. Just read this with me. It says that if a graph has x-axis symmetry, then it contains the point xy, but also the point x negative y. And that's shown down here in the graph. Here's a point xy. Well, here's a point x negative y. So if it's symmetric with respect to the x-axis, you can take any point on the graph, change the y value, just change it to the opposite sign, and that will give you another point on the graph. That's kind of a clue. If it's symmetric with respect to the y-axis, then it must contain the point xy, like this one here, but it also contains the point negative xy, like this point over there. All right. So in other words, if it has the point xy, it will also contain the point negative xy. And thirdly, if you look at this right here, this tells us that if a function is symmetric with respect to the origin, then not only does it contain the point xy, but it also must contain the point where both of those coordinates have their signs changed, negative x and negative y. So that would be a point like here and here as well. Down below, here's the test that you perform. These are the three separate tests that you have to perform to determine what kind of symmetry it has. So the algebraic test is if you replace y with negative y. Now remember, this is for a test of symmetry in the x-axis. You replace y with negative y, and if you get back the exact same equation that you started with, then you know it's symmetric with respect to the x-axis. For symmetry with respect to the y-axis, this is case number 2, replace x with negative x. And again, if you get back an equivalent equation, the exact same equation, then yes, it would show symmetry with respect to the y-axis. And the third test you have to perform to see if something is symmetric with respect to the origin, you replace x with negative x and y with negative y, and you determine if you end up with the exact same equation that you started with. That's what it means by produces an equivalent equation. And if that's the case, then you know it's symmetric with respect to the origin. So what we have to do here, let's look at some examples. You have to perform these three tests on each of these functions to determine what type of symmetry it has. It's a little bit time consuming. It can take a while, but it's not difficult work. Now, so we're on page 31. Let's look at example number 15 first. Now, this example here is not asking you to use those tests. What is this example asking? Well, it says if you have a graph of a curve, what if that curve contains the point -3 and 4? All right. So if the curve is symmetric about the given region, there's three parts here, three different regions, state a point that will also be on the graph. So you must tell me, what's another point that's going to be on this curve? So, part A. What if -3 and 4 is on a curve and the curve is symmetric about the x-axis? Well, remember what the test says, okay? If it's symmetric about the x-axis, then not only will -3 and 4 be on that point, but also the same point with the value of the y change. The sign of your y coordinate would change. So that would mean -3, -4 must also be on your graph. Okay, part B. What if this point -3, 4 is on your curve, excuse me, but what if the curve is symmetric about the y-axis? Well, that means that if you change the sign of your x-coordinate, that point will also be on that curve. So just change the -3 into +3, and the 4 stays as is. So there's 2 points that must be on that curve. And finally, for part C, what about if your curve was symmetric with respect to the origin? All right, well, to come up with another point that must also be on the curve, just take your original point right there, change the signs of both coordinates, so that would become +3 and -4. All right, so that's a very simple type of question. There's no real workings to that. You just have to remember, excuse me, which coordinates to change the sign of. All right, now let's look at example number 2. And this is where we have to perform those 3 tests that we were looking at. You have to perform them one at a time. This says determine algebraically if the given function has x-axis or y-axis or origin, symmetry, one of those 3 types, or maybe it has no symmetry at all with regards to either of those 3 things. So here's where we have to perform the 3 tests. Now I hope I've got room here to do this. Let me come over here. So here's test number 1. All right. What if I want to determine if it's symmetric with respect to the x-axis? All right, so just put a little question mark there because this is a test, remember. So what you do is you replace the y with -y, and you determine if you end up with exactly the same function that you started with. Well, let me see. If I take that equation and I'll replace the y with -y, and that becomes -y is equal to 2x cubed minus x. Now, of course, you wouldn't leave the negative in front of the y. Multiply both sides by -1, and look at what you get. -2x cubed plus x. Now, compare this new function, compare that new thing, to the original function that you started with. Are they exactly the same thing? Are they exactly the same function? And the answer is no, they are not. And so your conclusion would be that this graph, this function, is not symmetric. I'll just write SYMM. Not symmetric with respect to the x-axis. All right, now notice I didn't draw the graph or anything. I have no idea what the graph looks like, but I do know it will not be symmetric with respect to the x-axis. All right, let's do test number 2. Is it symmetric with respect to the y-axis? All right, so this is my second test. So what I do is I replace the x with -x in my function. So here's what I will get. Y is equal to 2. Now make sure that you put the -x inside brackets and raise that to the power of 3, and then minus and then replace the other x with a negative x. And now just simplify this as much as you can. So what happens is, of course, negative x to the power of 3. Well, a negative number raised to the power of 3 will also be negative. Okay, so that becomes negative x cubed multiplied by 2. So right away that first term becomes negative 2x cubed. And then in the second term you have a subtract minus x. Well, that becomes plus x. So now look at this. Compare this function again to the original one. And are they the same? And the answer is no, they're not. They're not exactly the same. So these functions do not exhibit, or sorry, this function here is not symmetric with respect to the y-axis. Now there's one more test we have to do. One more test. Now I'll just erase some of this so I can free up some space here. Okay. And the other test now, the third test is, I wonder, is the graph symmetric with respect to the origin? So this is test number 3 here now. Okay. So I'll just write origin with a little question mark behind it. And remember what the test now is. You replace the x with negative x, yes, but you also replace the y with negative y. So we do both of those things to the original function. Here's what you will end up with. Okay, so the y becomes negative y equals 2. Now replace the x's with negative x as well, so that's negative x to the power of 3 minus, and then I have a negative x inside the brackets again. Okay, now for the first step, I'll leave the negative y as is. Let's just simplify the right side, and again you have negative x cubed. Well, that's still negative. So that first term becomes negative x to the power of 3, and then negative minus x, or subtract minus x, that becomes plus x. So there's what you have after the first step. Now, get rid of the negative in front of the y by multiplying everything by negative 1, and here's what you will end up with. Y is equal to, and now all the signs change on the right side. So now you have positive 2x cubed minus x. Now, take that function, compare that to the original one that you started with. Is it exactly the same function? Well, yes it is. Look at that. It's exactly the same as what we started with. So our conclusion would be yes, this function, I don't know if I've got enough room. This function is symmetric with respect to the origin. Okay? And basically that's what you do for all of these examples. All right, so I'm running out of time here now, but I'm going to leave B and C for you to try. We can even go over those in class if you like, as long as now you've seen what the technique is. Also try practice number 15 on page 31, and also the practices problems on page 32. Now the ones on page 32, that's where you need to perform your 3 tests, okay? So I'll stop there. Now we're not quite finished this section yet because I've got to go over odd and even functions next. So anyway, I'll stop the video there, and I'll see you later. Bye-bye.